to this channel again, and today we are going to solve binary search problems. We are going to solve a problem which is called find first and last position of an element in a sorted array. It's a medium level question on lead code. So what it says is you will be given a target element and you will be given a sorted array. All you need to do is find the first occurrence and the last occurrence of the target element in the array. Okay, now let's think about it, right? Let's think about when I taught you lower bound. I have given you the definition, right? Lower bound is the first index of the element which is greater than or equal to the target element. And similarly, upper bound is nothing but the first index of the element which is strictly greater than the target element. In this example, if I want to find the lower bound of 8, this will give me the first occurrence of 8. And if I find the upper bound of 8, this will give me the element which is just greater than 8, right? It will point me to this particular index. So can I say the first occurrence is equal to the lower bound, whatever the lower bound will give me, and the last occurrence is equal to the upper bound of this target element minus 1, right? This does make sense, right? The upper bound will be strictly greater, so it will come here, and I'll just decrement 1 from there. It will again reach to the element. Now, one more thing. Are you able to relate this? So upper bound of a target is nothing but lower bound of target plus 1. So if I'm trying to find lower bound of 8, okay, in this example, let me copy this one. It will make more sense. And if it is making sense to you, then well and good, right? You're already good at this. So all I'm saying is, so lower bound of, let's say, 8 will be this. But what will be the lower bound of 9, right? So lower bound, I'll write it as LB. Lower bound of 8 will be 0, 1, 2, 3, 3. But what will be the lower bound of 9? It will be 5, which is equal to upper bound of 8. So this relation always stands true. The upper bound of any target is equal to the lower bound of target plus 1. So if you find the lower bound of target plus 1, you will get the upper bound. Now this is what we are trying to utilize here. Now let me get my generic template for solving any binary search problem. Okay, so what I need to do is basically I need to find the lower bound, and can I say this function name as lower bound? Okay, and if you see, this condition is matching with our lower bound only. So right, so what I need to find is, in this condition I'm only checking if the mid value is greater than equal to the target element, and this is what the condition for the lower bound also. The element should be greater than equal to the target element. Simple. This is the condition, right? This is the condition which should get fulfilled. So in this condition function, I will write the condition which should get fulfilled. And the condition that should get fulfilled is the element should be greater than or equal to the target element. Otherwise, I will return minus 1. Now, the starting position, right? As I mentioned, the starting position will be lower bound of the target element, and the end position will be lower bound of target element plus 1 minus 1. Does this make sense? It should make sense, right? Because a lower bound of target plus 1 will get me to a one higher value, the starting position of one higher value, and I'll just subtract minus 1 from here. Now instead of subtracting from here, I'll just like hold it for now, right? I know like this end is not actually at the end, it is one more than end. Okay, now see, there is a possibility that this target is not even exist in the array. If the target does not exist, then in that case I have to return minus 1 comma minus 1. Okay, I can check this, right? So this lower one will give me, if the target does not exist, it will give me the element. So let's say in this case, if I'm searching for 6, the lower one will give me 7 here. I can check if target does not exist. But what I can do is basically I can check if in the nums of start, if this is not equal to the target. So if target exists, then this lower bound will got set into the target only. So if in this case, if 8 exists, it will be pointing to 8. In this case, if 6 does not exist, it will point to 7. It won't point to 6, right? So if this is the case, then blindly I can say, okay, this number does not exist. All you want to do is return -1, -1. Okay. Now here one more thing can happen. So if the array is empty, in that case, the lower bound will give me -1. And if you check in the edge case, nums of -1 will give me index out of bound error. So in that case, I should be very much careful about it, and I am just managing an edge case here. If the array is empty, it will give me -1, and if it is giving -1, then I should return -1, -1, this input. Now there might be a possibility that I have this array, and what will happen is it contains 888 and my target is 8. Now my lower bound will come like this, but lower bound of target plus 1 will come as -1 because nothing is there, right? It will come as -1. So if it is coming as -1, that means so my start is having something, but the end is -1. That basically means that from starting till the end of it, I have my target element. So if end is equal to -1, then I can say that I should return the start because it is starting at some position, and for the end I should return n -1, which is the end of the array, right? I should write it as n will be equal to nums dot size. And if it is satisfying this condition also, then all the edge cases have been met. So this is starting edge case, this is ending edge case, this is not present target edge case. All the edge cases have been resolved. Now all I can do is return, like the last case is basically it will fall between somewhere, like in this case 8, 8. All I can do is return start and end -1 because obviously this end is pointing to 1 greater than the end index of the particular target. So I can return this. Okay. Let's try to submit it. So we are using this, the generic binary search. Let me run this first and see if it is passing all the test cases. Okay, I'm getting a compilation error here. Lower bound has too few target. Okay, so I need to pass array also. I can't pass the target only. Okay, let me run again. Okay, it has been accepted. Let me submit. Yeah, it has been submitted successfully, as you can see. Cool. So this was your problem. Find first and last position of an element in a sorted array. How we solved it is we wrote our generic binary search code for lower bound because lower bound is the starting index of an element, and we utilized our upper. We also wanted to calculate upper bound, but we came to realize that okay, upper bound is nothing but lower bound of target plus 1. So we utilized the same method twice. We called lower bound twice, and we took care of some edge cases. So in interviews, it is very, very important to take care of all the edge cases. Think about all the edge cases when you are going out of the array from right side, when you are going out of the array from left side, right? What will happen if you are falling in the middle? Then what will you do? It is very, very important. Just take care of these scenarios when you are sitting in an interview, and also like try to explain everything as I did whenever you are giving an interview. And then also the variable names I have used, it is important for you to use meaningful variable names. I'll be solving more problems in future videos, and we will take care of all the best practices of how you should take some interview. So that's all for this video. See you in the next one.